All right, so we are going to spend a little bit of time reviewing what we did 2 weeks ago in Pandas, and then we're going to go on and talk about some advanced Pandas that I think you'll find useful in the data wrangling, data exploration portions of your own personal projects. And then we're going to spend a good amount of time, as Sinan said, talking about the IRIS data set, and that's going to be an interactive exercise where you guys are going to try and explore the IRIS data set on your own. And so with that being said, I just wanted to quickly highlight a couple of points from the class 2 weeks ago on Pandas. So this is sort of the introduction to Pandas. So as you'll remember, Pandas is the library very popular for doing data analysis in Python. It stands for panel data analysis because everything's organized in a matrix, a tabular format. The data set we used last time was this UFO data set. And so we'll be using that for part of the class today. We talked about different ways to summarize the data set, one of those being UFO.head, or the data frame with the head method. We talked about how to slice and filter and sort your data and different ways of doing that with the .loc method and the .iloc method for referencing and filtering data by the labels of your data for the .loc method, and the values in your data, the position of the columns and the rows in your data with the iloc method. We also talked about logical filtering, which is filtering an entire data frame based on certain attributes within specific columns. So taking a whole slew of observations and filtering them to only see the subset of observations, the subset of UFO sightings in Texas. We also talked about sorting and different ways of sorting and how you can sort. You have complete control over how you sort in your data set. We talked about detecting duplicate values and how to show only duplicate values, how to count how many duplicate values you have, how to show only unique values. We talked briefly about how to modify columns, how to add more columns to your data frame, which is a really important part of machine learning, sometimes called feature engineering or model specification, figuring out additional information to extract from your data set, how to just simply rename columns when the names that are given are either descriptive or unwieldy. We also talked about missing values, how to find missing values, how to change missing values, how to filter by missing values. And that's really where we stopped. So a lot of very basic things that you could do, you should be able to do in really any software that you're trying to analyze your data in, but things that are really useful to know. So what I wanted to spend the majority of the walkthrough on today is getting into continuing to analyze data. It's the same data set in Pandas using some of the advanced Pandas functionality. But before going on to that, I wanted to stop and ask if there was any questions about sort of this basic level of Pandas functionality. Okay, so let's move on. So the file that I'm going to be going through today is this file called o3_pandas.py. So take a moment to open that up. And the first thing that we're going to do today, the homework assignment for last week was reading in a data set called the drinks data, and it showed alcohol consumption, different kinds of alcohol consumption, and alcohol consumption over different countries and different continents. And so what we're going to start off today with is a fun topic, plotting, and Pandas actually has a plotting functionality, so we're going to talk about that with the drinks data set, and then we're going to go back to the UFO data set and go into some additional advanced functionality in Pandas. So first of all, we're going to go ahead and read in the drinks data set. The first plot that you'll see in this data set is a plot that shows you code that shows you how to create a bar plot. The thing that is sort of nice about plotting in Pandas, there are pros and cons to different approaches of plotting data visualizations in Python. There's different packages for doing it. The way the Pandas plotting works is that it's actually a wrapper. It's a convenience wrapper around a package called matplotlib. And you see on line 17 me importing the matplotlib function. Yeah.
Online, I have the option to do the Python console or the regular console. Is there any difference between that when we're running the code?
There's no difference in terms of the code that's actually going to run. What will be different is the way that you see the code being run. And so the IPython console it tries to interpret the best way to visualize the output of the script. And so it'll include some formatting that you wouldn't see in the base Python console. But in terms of the Python interpretation, it's the same Python interpretation in both.
Do you recommend us to run one or the other?
I've used both. I like both for different reasons. I tend to go with the base Python because it makes less assumptions about what I want, and I can have a little bit more control over it. But IPython can be nice as well. It has some additional features. So, yeah. So the draw of using Pandas for plotting, and the reason why I'm actually choosing to teach Pandas for plotting, is not that it's the only way to do plotting in Python, but it's a very intuitive way, I think, to do plotting in Python, because it essentially consists of taking a data frame, structuring it the way that you want it to be structured for whatever data analysis you have, and then a lot of times it's just as simple as calling the .plot method. And then specifying arguments about the kind of plot that you want to see. So here you see a great example of this. Basically, I have the drinks data frame that I've read in, and I'm saying select the continent column label and run the value counts on the continent column. So can anyone tell me what the value counts is going to do in this situation? Yeah, it's going to. Well, let's find out. So it's going to count the number of drink entries by continent. So it's going to look at this continent. It's going to look at this continent column, and it's going to say how many records are there for each value in this continent column. So it's a really helpful summary statistic that I use a lot for categorical variables. So now that we have this, let's create a bar plot. So when you run that command, you see the same information that I just printed out, but you see the graphical representation of that information. So this is, again, one of the draws of plotting in Pandas, is that it has a very intuitive interaction between the plotting and the data that you're plotting. You format the data you want it, the way you want it to be formatted, and then you call the plot method. What you see afterwards is some formatting that labels the X and Y axes, and you see before the formatting this PLT, and this PLT is a reference to the matplotlib package, which is the package that Pandas plotting is essentially just a convenience function around. Okay, so when you do the labeling, you typically do the labeling with you can call additional matplotlib commands after creating your plot, because you are creating your plot using the matplotlib package. You just don't see it because it's in the background. And then here's a command if you want to create a script that will actually save a image of the file that you created. You can go to wherever your current working directory is, and I'm going to show you where that is right here. and it should be saved right here in the code file. So I created this file, countriesforcontinent.png.
Mine did the same thing.
It's because I probably forgot to type in the plt.show. There we go. I forgot to run one of the commands, the show command, which actually creates the graphic. So there you go. That's a rather simple plot. Let's go to another simple plot that you might be interested in looking at. So that was just sort of a bar chart, how many counts of a certain value by a different categorical description. What if you want to see a distribution of a numerical column using a histogram? It's actually as simple as just referencing the column, the numeric column that you want to see the histogram of. And in this case, I'm going to look at the beer servings column. And so I just select that column using the period operation, and then just call the hist method. Wait a second. There we go. And here you see on the x-axis you have the beer servings, and this is again each of the observations in this data set is one country's average beer serving per year, and then you have the count of how many countries fall into each of these buckets. How many buckets are there? Well, you get to decide that with this bins parameter, and here I chose 20. And then you can format it as well if you'd like. Let's close out of that and go to the next one. A density plot is essentially the same kind of thing as a histogram, except instead of bins, you have a continuous line, and the default setting shows you the percentage of observations in each bucket. And I think the default bucket is just 1, so you can interpret this as 0.5% of all beer servings are in this bucket here. So maybe that's the 10 bucket. Yes.
For histograms, the bins argument seems kind of clumsy. Like, why would you have to know how many bins that you need to create a histogram? Like, wouldn't you have to look at the data and then do some kind of mental calculation to be like, what would make the most sense with this distribution of data, and then like manually put an argument? Is there a more efficient way to do it than just say, let's type in 20?
Yeah, I mean, you can pick whatever you want to. So if 20 doesn't look right, then you can say like 20 is too much. You can change it. But I mean, making these visualizations is usually an iterative process. Okay. But visualizing it, seeing if it looks good, and then changing it. I've all the visualizations that I've done in Python have always been very iterative in terms of, this looks good, it doesn't look good. I mean, you're not seeing that in front of class 8, so I thought about these visualizations, and you're not seeing all that. But yeah, there's a lot of back and forth, so that's a good point. A lot of variability that can be involved in creating these visualizations. Yeah. Good question. Good question. So what if you wanted to do the same histogram as before, but you want to split it out by a categorical variable, in this case by the continent? Well, the hist method in Pandas actually takes this as an argument, and so you see the same thing as before, the same thing as earlier, but instead of just showing the bins, and I actually don't specify the bins argument here, I'm also specifying the drinks continent with the by argument. And so what you see pop up is sort of what you'd expect, I think, just showing the histograms by each continent. So this could be useful for looking at differences between continents in terms of the beer servings, or differences within each continent in terms of the beer servings. Depending on what you want to do, there's arguments to control whether the x-axes are consistent throughout or whether they're adjusted based on the particularities of that category. And so that takes the form of share x and share y. And so you see those in the next two examples. Share x true equals true just means all of the x. You see the x-axes on these upper plots disappear because they have the same range for all plots. The same kind of, and you can see the y-axes are different for all the plots. They're adjusted based on the data in each plot automatically. That's the default setting. And so you have Europe has higher beer servings than Oceania. So that's just because of the data in that particular category. But you can change that so you can more accurately see differences between different groups by making all the axes consistent. If you're more interested in looking at differences within continents, then maybe it might be better to not share the y-axis. Yeah.
So if you want all the histograms to be
Yes, you can. Yes, you can. I've seen that. I don't know how easy that is. I would refer you to the documentation for that one. Was that? Is it as easy as just adjusting a histogram argument?
You can. So I mean, technically, in that plot, if you try to graph two together once, you'll just put them on the same graph without clearing the screen.
But yeah, that's obviously not.
But that's not. Yeah, it's not great practice because then you do the scalings, and you can do this, different that. Matplotlib doesn't do very well with multiple axes, multiple type, things like that. But there are times that will be graphing multiple things in the same plot. That's because they were specifically designed to have the exact same scaling, so it actually makes sense to put this like that. That makes sense?
There's actually so what I'm going to be covering in class today is just sort of the tip of the iceberg in terms of plotting. I actually included a link to if you go to the GitHub repository, the first link under the resources section for this class is a slew of examples in the documentation that show different examples. So maybe this is something you might be interested in, this kind of thing. So you can just sort of look for what you're interested in. You can see there's quite a few examples where there are different versions, different ways of overlaying multiple graphs over top of each other. And so the good news is that if this has what you want, it's as simple as copying and pasting the code off of this. Yeah.
But it's not the best plotting device in the world, so I wouldn't rely on Python to make all the graphing all the time. Some cool stuff, yeah.
Yeah. So this is the first link under the resources section. It's right here.
It's just
It's just the Pandas documentation.
yeah.
It's nice because it's quick and it's easy, but the downside is that it is rather limited in terms of what it can do, and maybe some of that will be developed in the future, and I would certainly hope so. But it's nice for generating quick data visualizations. A lot of the formatting is taken care of for you. You can also control the layout of the different visualizations. So that's the last example there. Another command that you'll find useful in, and actually I would say all of these commands, but these commands are commands you'll find useful in the exercise in class today, so you'll be able to reference back to this hopefully. Let's say you wanted to show a box and whisker plot of, again, let's go with the beer servings and look at the different median values and the distributions for the beer servings by continents. So that's an example of that. Scatter plots are called with this generic plot method and then specifying the kind of plot that you have. And so here I'm going to say use the plot method and then say kind scatter plot. I think that in the future they're going to try and move more and more of these plotting techniques to this sort of general interface where you can just specify the kind, but not all the plotting methods are currently there. But the scatter plot is one of them. And so here I'm plotting two different continuous numerical values against each other to see if there are any groupings in the data, to see if there's any patterns or relationships there. This is another plotting technique that I get a lot of use out of, and you will too. during the exercise today. Another thing you can do is you can specify here's an example of basically just doing the same plot but having color, specifying how you want the different observations to be colored. So coloring them with this particular color scheme here and making the colors dependent on a third variable, so visualizing a third dimension.
Can you build on that and then do like a best fit?
Yes, you can. So if you were to train a model of some kind, you could also call another plot command after it and have it appear on the same plot. So you have like two different data visualizations, one showing the original data and one showing the line best fit. Yeah, and all of this is just sort of a very brief introduction because I want to give you guys some tools to help you start exploring your data visually. But plotting is one of the things that we will be continually coming back to in the class, and we'll be doing throughout the class. So when we do linear regression, there'll be a lot of plotting in that class. When we do clustering, there'll be a lot of plotting in that class. So
I'll do some more plotting with
this
the
is
command too. So
yeah.
always plotting, always visual.
Yeah. So we're trying to weave it in throughout. We're not spending a ton of time just devoted to plotting right now because of that. Let's say you wanted to color by a categorical variable. This is probably one of the most disappointing things for me right off the bat about plotting. Coloring by categorical variables, it's not very intuitive to me in the same way that plotting by the continuous variable was earlier. I would love if I could just say, here's my category, and then plot all the colors according to that category. It doesn't seem to work quite like that yet. Maybe in the future it will. Here what I'm doing is I'm saying, if any of the continents are Europe, then give it a red label, an R value, or else give it a black value. You can picture a for loop that goes through all the continents and specifies colors for each content, which in my opinion is not very elegant. I hope they improve that aspect of the plotting feature, but
It's very similar to the Pandas. So does anyone remember how Pandas logic filtering works? Like the dirty secret of Pandas. How does the logic filtering work? Anyone remember? So if I have a data frame of 100 rows, how do I tell it that I only want the ones that are Europe? You say whatever data frame content equals Europe. And what does that do? It makes a list of 100 trues and falses and then passes that into the data frame. Remember we were like fudging the data by throwing it random lists of trues and falses just to get random rows? This is kind of the same thing. All you're doing is you're giving it a list where there's 100 different values where each value is a representative of a point, and if it's R, make it red, if it's B, make it blue. So all it is just giving it a list of however many points you have, and then the value is the actual color. So you're right, it's not the most elegant solution, but it's kind of the most naive and simplest thing to implement. So that's what they did.
yep. Yeah. You don't. There are other packages out there. I haven't used them or explored them really, so I can't speak to them personally. But you can do a lot of really easy stuff with Pandas, and especially if there's already like an implementation of something, it's going to be really easy to implement it. If you want to get more complex and have more control over what you see, you can go to the matplotlib, like the actual library itself, and that will give you some more control over the formatting and the arrangement and the orientation of different graphics that you're creating. But that being said, there are other packages out there. One that I know of is called Seaborn. I haven't used them, so I actually don't know how good they are. Yeah. Another thing is if you have background in R and you want to use the ggplot2, which is a fantastic data visualization library, you can actually call R commands within Python. And so I know some people like to, we're not teaching R in this class, but I know some people do like to use Python for everything except for data visualization, and then use R for data visualization because they like it better. But
You don't have to leave Python to block R.
no, you don't. Yeah. So I think the, what's that?
Is it the same code?
It,
It's like call R and then plot like the same code.
the code is R code, but you call the R code within a Python script and a Python interpreter. Yeah. Yeah.
My question about the box plots.
Yeah.
Do you mind explaining how this works?
Yeah, absolutely. Let me go back to the box plot. So like this one, for example.
Yeah, but what am I looking at there?
So what you're looking at is on the x-axis the different continents, on the y-axis the beer servings, and you're basically just looking at the distribution of beer servings by continent. And so what do I mean when I say distribution? What I mean is some basic summary statistics about the underlying data per continent for this continuous variable. So in Asia, this red line is the median of the beer servings for this continent, and you can compare, Europe, the median is much higher. But it doesn't just show you the median values, which not by itself doesn't necessarily tell you a lot about your distribution. It also shows you the range. And so what I think it's showing you here is actually the lower and upper, the lower 25th percentile. So all 25% of the beer servings in this continent are below this value, 75% are above this value, and then here's the 75th percentile value. I'm not sure what exactly this one is. I'll have to look at the documentation again.
Outliers, the box is interquartile range.
Yeah, this is I believe this is the interquartile range. This might be like 2 times the standard deviation or something like that. It's obviously not the maximum value, but you can adjust these parameters to show you what you want to see. I don't know. Does that help? So you're just looking some summary. It's very similar to like if you were to just do drinks dot beer servings dot describe. Yep. And you see these summary statistics. You see the minimum value, the maximum value, the 50th percentile, the 25th percentile, the 70th%. It's just a way of visualizing that kind of information.
Gotcha.
Does that make sense?
Yeah.
Yep.
It's an interesting thought.
So it's just a way. It's really a way of comparing different groups to each other. You can also see whether skew is present in your data, whether your data tends to be skewed in one direction or another, which has relevance for doing statistical testing. Okay, the last plot I'm going to show is actually one of the plots that I use most frequently. It's called the scatter matrix plot. And the scatter matrix plot basically shows you the pairwise relationships between the variables in your data set in a matrix format. So you see all 4 variables on the x-axis and again all 4 variables on the y-axis, and you see each relationship, each combination of relationships between the different datas in your data set. And you also see along the horizontal, because it wouldn't be very insightful to say, what's the relationship of beer servings to beer servings? It shows you it sort of infers that would not be useful. So it shows you the distribution. Here is basically the distribution of the beer servings and all these different variables. One thing you will notice in here is that it automatically left out the continent and the country because they're not numerical values. And so it will automatically just take the numerical values. If you have a variable in here that's codified like as a 1, 0, and it's meant to be maybe a 1, 2, 3, and it's meant to be a categorical variable, but it's recognizing it as an integer, it'll still show up here. And there's a couple things this kind of plot is useful for. One thing would be looking to see if there are any categorical variables in your data set that you might have missed, and you'll notice that because there will only be like 3 bars. It's like 1, 2, and 3. Oh, that's probably a categorical variable. A second thing that this is useful to see is just the relationships between the data. So is there a correlation, for example, between the amount of beer servings in a country and the total liters of pure alcohol? Well, one is a subset of another, so that might not be the most interesting relationship, but there does appear to be a relationship there. The other thing that the scatter grid is useful for is observing different properties about your data set and maybe groupings within your data set. So something you can do is actually include you can see maybe different clusterings of data in your data set, and we're going to be talking about clustering later in the class formally, but clustering just being, here's a group, and there seems to be a bunch of observations, and there's not really any great examples here, but imagine there's not a lot of observations here, there's some observations here, there's some observations here. I might lead you to ask the question, well, what's the difference between these two different groups? Is like the east and the west region of a country? What's going on there? That's a scatter grid. This is a nice handy grid that I use all the time for exploring data. So with that being said, that's all I'm going to cover for data visualizations as such. But that being said, this is just the tip of the iceberg, and we're going to cover a lot more with regards to data visualization going forward as we cover topics that sort of require a lot of data visualization. But that being said, any questions about any of these visualizations?
Sorry, is
Yep.
it possible to make them interactive at all, or is that like?
So that's a good question. I haven't seen interactive. There probably is a way to do it. I haven't seen interactive graphics. Like if you wanted to like put it up on your website and make it interactive, I haven't really seen that. I mean, I'm sure people have developed things within Python for doing that. Yeah. What's that? Mathematica.
Or you can put it down on top of it.
Yeah.
I'm sure you can do that.
I know R has Shiny, which is the popular option for interactive data visualizations for the web. What I use is D3. Like I think D3 is a JavaScript library. I think that's like far and away, like not even close. I haven't seen anything come close to that in terms of interactive data visualizations for the web. Like if you have a blog or a website. I don't know, Sinan, would you add anything? Do you have any, what do you use?
So, depends on what I'm doing, obviously. But for like websites that I create, I want to fairly simple, like stock graphs or bar charts, like still like not interactive, but just very visual and nice and optimized for the web. There's something called high charts.
Yep.
High charts, like HIGH charts, highcharts.com, which is like a library full of some of them are interactive, they are. Some are sliders and all that. And it's very out of the box functional.
Mm-hmm.
D3, I feel like it's a learning curve. We have that.
Yeah, definitely.
D3.
Definitely.
High charts is very like drag and drop, like this is my graph now.
Mm-hmm.
I like high charts.
Yeah.
Because I'm not very good at it. That's really because I'm not good at it.
Fair enough. That is true. I mean, there's definitely a learning curve with D3. But if you have a web background, if you have a JavaScript background, it'll be much less so. D3.js.
Is it its own language, or is it?
It's not a language, it's a library built with JavaScript. So you don't have to know JavaScript to use D3, but if you start using it, you'll learn JavaScript along the way because it's built on JavaScript. Yeah. Maybe I'll Slack some links out to some cool D3 visualizations. For any of you guys who read the New York Times, you've probably seen a D3 data visualization because they love D3. If you've seen a bubble chart in the New York Times, it's probably been a D3 because they love their bubble charts. Okay, so moving on. Let's get started in Pandas, and then we'll take a quick break momentarily. So let's go back to the UFO data set and find some interesting things about these UFOs. So I'm going to read in the data set, and I'm going to rename the columns, which I had done in the previous class, so that the rest of these commands work. And what I want to talk about is indexing. And this is just sort of introduction to indexing. Indexing is something that I use a lot in all of the data wrangling that I do. And I think one of the reasons why people like using Pandas for data wrangling is because of this very intuitive and very elegant indexing that Pandas implements. So, so what is an index? An index is basically a way of breaking up your data. It's a way of calling your data. It's a way of filtering your data. It's a way of sorting your data. It's basically a way of letting you manipulate and wrangle your data and put it into the format that you want it to be in. So what I'm going to do is show you basically just the syntax for a lot of this stuff. It's stuff that I have found to be very, very useful in my own personal analyses. So first of all, how do you create an index? First of all, when you're reading a file and you don't specify anything, it'll just give the default index is just numbers. So you can see the index here for the row labels is just numbers starting at 0, that may or may not be useful for what you're looking for. What I'm going to do is set the index to state. So I'm organizing my data by state, and now you see that I have the state here on this column. And you see also that the state is no longer one of the columns. It automatically removed that from the column and placed it as an index. The way to sort of get access to the underlying data in this index is just to call the index attribute, and you see this index object, and you see all the different values here. You don't see all the different values, but you see quite a few of the values here. There's an attribute called isUnique, and it checks whether there are duplicate values in your index, and in this case, it's obviously false. Yes?
What does the U mean before each value of the index?
So U here is, you see how these are strings? U just stands for Unicode. It's essentially a way of, it's basically how the characters in Python are being interpreted.
Like for example, if you were to import Chinese text,
Yeah.
the code wouldn't work.
Yeah.
You would know what to do, it would fail. You have to do a Chinese encoding, which have their own encodings, and same like Indonesia and Turkish, they'll have their own encodings.
Yeah. Yeah.
UTF is just the universal, but it still can't handle a lot of the providers out there.
Mm-hmm. Yeah. isUnique is just checking to see if the index that I just created, that's now the index for the data frame, is actually unique or if there are duplicate values. Yeah. So let's go ahead and reset the index with just calling the same command as before. And now I'm going to set it to city. Let's see what happens now. So one thing you'll notice is that the city is now the index as we sort of expected, but the state index that we had created before is no longer there. So it just deleted it. Like it deleted it previously from being a column, and now it's no longer there. So what we instead should have called, if we wanted to have the city and the state as both being indexes, is to use the append argument and set that equal to true. So I'm going to go ahead and read the data in again to get that state value back. And I'm going to set the index again to state. And now instead of calling just the set index, the first set index command, I'm going to call the second one, which has this append equals true. And that's going to append the index that I'm saying onto the previous index. And so now you see what you sort of would expect to see, or what one might want. You can also sort index, and let's look at the index again. Let's look at the first 40 values, and you can see that the printing out is kind of nice here. It just shows you for this state, here are all the different cities in that state, and it's sort of laid out like you'd picture a pivot table if you've used pivot tables in Excel before. So as I mentioned, indexes can be useful for slicing your data. So I'm just going to use the .loc method again, and I'm going to select the UFO sightings in the country of the state of Wyoming. And so when I select that, you see that I have the city index, but I no longer have the state index because it's no longer necessary. I specified just that state, and so it's interpreting that for me, not showing that. I can specify multiple states. So here you will see the state index appearing because I have multiple states. So those are two specific states. Here is everything from North Dakota to Wyoming. Whenever you make this kind of selection, the first state has to appear at least once before the last state. So this interprets it as start and end, and those are inclusive. So that's basically selecting with a very simple select statement, continuing with what we had sort of done before, but except with indexes versus with columns. So let's say you want to reset your index and you want to have those values back as columns again. You can do that by specifying only a particular level that you want to reset. So here I'm just going to reset the city level. And let's see. The city is now a column again. And you see the state there is still as an index. Or you can reset the entire index just by not specifying anything. And the default is just to reset the entire index. And so that takes all of your index values and places them back as column values. And you see this default index appearing there. So if you want to set a multi-index just in one fell swoop, you can do that with a list of columns that you want to use as your multi-index. And so here I'm using state and city. This is essentially doing the same thing as before, but I'm just doing it in one line of code versus doing it one at a time. So I won't belabor that point. If you want to slice using a multi, and let me actually just run this command. So now you see just what we saw before. If you want to slice using the multi-index, you can specify which values you want to see using the tuple inside of the location method. And so here I'm specifying I just want to see observations in the first level for North Dakota and the second level for Bismarck, North Dakota. And you can do ranges of values in the same way. So here we go. And I mean, this is something that if this seems repetitive, it sort of is repetitive. This can be done with logical filtering. It's just a little bit more clean and elegant to do it this way. So any questions about what I've done so far with the indexing, multi-indexing? Yeah. Okay.
Anyone have questions? Yes.
So actually, run from this goes
Okay. So I included a section on analyzing across time, but it's 11:24 right now. Let's go ahead and take a quick break, and we'll come back in 10 minutes. So 11:35. All right, let's go ahead and get started. Back up again. We'll spend the next 20 minutes finishing up the pandas portion, and then I'm going to turn you loose on a new data set you haven't seen before, the iris data set, and let you guys exercise all these new skills that you've learned. So with that being said, let me go back in. I was doing some things for an example. Let me go back in, and I'm just going to reread the data in, and I'm going to just keep the default index for right now, and move onward. So I included a section here on analyzing data across time. I'm not going to go over this right now because of the time that we have, but Pandas is nice for analyzing across time. The one thing I would say in my experience is that analysis across time works best when you have the time variable in the index, and that's the way that you're indexing your data. And then once you have it in the index format, you can do pretty much everything you could imagine wanting to do with time. I included some examples here of some things that I find to be useful, but that being said, there's a whole section in the Python for Data Analysis book and the website that goes into much more greater depth on the time aspect of analysis. So what I'm going to actually do for now is to just actually run part of this code. I'm just going to format the time, and I'm just going to run this entire section, and I'm doing that to create some variables, and I'm doing that to format the time. So I'm going to create variables for year, month, day, weekday, and hour, and you're going to see a lot of things print out. So go ahead and run that command, run that entire section. Down through the entire section, so it should be line 162 is where you stop at the split apply combine is where I'm at right now. So everybody good with that? Okay. Okay, so now we're going to talk about something called split apply combine. If you have a background in, how many of you have a background using SQL, where you're like you know SQL? You could like just sit down and write SQL queries. Yeah, a couple of you. Okay, excellent. So this is probably going to be really intuitive for those of you who know SQL, but the split apply combine is one of my favorite aspects of doing data wrangling in Python. And what the split apply combine does is essentially take a data frame and split this data frame into subgroups. We'll just call them groups right now. So let's say we can split the data frame into the groupings of years. So each year notes a group in the data set. And it applies some kind of function on each of those groups in your data set, and then it combines those data sets together again. So let me just draw what that actually looks like on the whiteboard here. So let's say you've got a data frame, and you've got two variables. One is a categorical variable and one is a numeric variable. So this is 1 and 2, 3, 4, 5, 6. And here we have A, B, B, C, C. And what split apply combine does, let's say in this example, we're going to split along X, the X variable. And so what that does is it creates 3 groups of data, one for each categorical variable. So here's A, B, C, C. And 1, 2, 3, 5, 6. So this is the split component of the split apply combine. Then the apply, you're going to apply a function. So in this case, let's say we're applying an average function. And so for each group, and we take the average of what we specify. So we're going to say, take the average of the Y variable. And so here, it's going to be 1.5, 3.5, and 5.5. And then the last step is combine. So this is split, apply, and then combine. And so now we're going to get a new data frame that is has the categorical variables that you use to split and the numerical variables that are the result of whatever function you chose to apply and the column you chose to apply on. Okay? And in Python, in Pandas, the result of a split apply combine is a series. But as you'll remember, a series is just a data structure, a labeled data structure with one column. And it's trivial to go from a series to a data frame, so they're really concepts that work together. But you have a series, and you have the metric that you use to split your data along with the result of the function that you apply to your numerical data. So this is a really powerful construct for situations, first of all, when you're just trying to get summary statistics of your data. So let's say you want to get a count of values. Remember earlier we did the value counts method? And so the value counts, it took a count of observations by one of our categorical descriptors. So we had a count of variables by state, or a count of drinks, observations by continent, which is essentially a count of countries by continent. That is essentially a split apply combine. It's splitting the data, so on the back end, it's splitting the data along whatever variable you select, the continent variable or the country variable, and then it's applying a function, in this case a count, the count function, a very simple function, and then it's grouping it back together and it's displaying the result. Okay? The other reason you might want to use a split apply combine function is when you're dealing with data that's in a certain format and you're trying to transform it into a different format. Okay? So an example, in my work, sometimes I analyze transactional records. And so transactional records are great because they're very granular. There's lots of information stored in them. But they're not in a format that I can analyze necessarily by just in that raw format. And so what I take is transactional records and I'll group them by maybe the user. I'll group them by the day. And I'll calculate certain metrics from those transactional records. And the resulting data frame that I do all of my analysis on is in a completely different structure and format than the previous, the original raw format of data. So I would say those are the two reasons that you use the split apply combine routine. Let's go through the syntax. So actually, any questions about the split apply routine and what it's doing at a conceptual level? Okay? Yeah.
So it always gives the series of the mean value. What do we do? The apply and the combine?
Mm-hmm. So for the apply, this example was the mean. The function that was applied was the mean. But the apply function can be any function you define. Some of them are predefined in Python, like count, max, mean, median, these kinds of things, very, very basic things, standard deviation maybe. But you can do a lot more sophisticated things by defining your own functions.
This is basically a visualization.
I would say it's a transformation. And it's something you can visualize if you want to, but you don't necessarily have to. Yeah. Okay. Yes?
Sorry to make you repeat. Would you mind just repeating the two real-world reasons to split apply?
Yeah. I would say, so this is, again, in my experience, the two reasons you would use split apply combine would be, one, to just get some summary statistics in sort of exploring your data. So like, I want to know how many observations, how many UFO sightings in each state. Which state has the most UFO sightings? You know? The other example is to transform the actual structure of the data. So let's, right now each row is a UFO sighting observation. Maybe what I really care about is statewide trends in UFO sightings. And so I want each row to be a state, not a UFO sighting, a state. And then how do I want to describe the states? Well, I want to pull out what was the earliest UFO sighting, what was the latest UFO sighting,
What was the count of UFO sightings? What was the 3-year running average of UFO sightings for the last 3 years? What is the population in the state? And so that's a different kind of analysis, or an analysis that requires a different structure of the data. And the split apply combine routine helps you build that transformation, that new structure. Make sense? Okay. And for those of you who have SQL experience and done this before, feel free to elaborate on anything that I'm saying. But that's what I use it for. And this is actually probably one of my favorite parts about doing data wrangling in Python, because I think it does this very well. So here's an example. So basically, whenever you do this, the first command, split apply combine, you define a grouping. And so here I'm going to group by the year variable. This is a variable I created. And so I'm going to take a count. I'm going to group by the year. So the splitting is occurring along the year. And I'm going to take the count, which is the apply part. I'm taking a count. And what am I taking account of? I'm taking account of the city. Now, this could be any column, but here I'm just choosing the city. And I'm just taking a count of how many cities are there for each year, just to get a sense for how many UFO sightings there are for each year. And so it's splitting and it's combining, in this example, along the year variable. So here I'm going to get that. And you can see, here you can see the result. It's like I said, there's a series. You can see the first year, and it goes all the way down to the last year in the data set. Another standard function is the minimum. So here I'm going to group by the shape, and for every shape, I want to find the lowest year value. So the apply function here is minimum. I'm applying it on the year column, and I'm grouping and applying across the shape variable, the shape category. Does that make sense? Okay. You can also, like I said, you're not just restricted to these standard functions. You can define your own functions, and here's how you do it. It's the apply method. So the same thing as before, but instead of just typing in max, this time I'm going to use the apply method, and then I'm going to call the anonymous function lambda x, and then I'm going to say for this x, so the anonymous function is taking an input and it's doing something with it. What is the input in this case? It's a grouping of the series that you're passing it in this case. And the series, the column is year. So it's taking the year, and for each grouping of the year, it's applying this function just as before. And this line here is equivalent to this line. They're both finding the maximum year for each shape. Here I'm using the standard Python way of doing it. Here I'm using the custom function way of doing it. And so if I was just interested in max, I probably wouldn't do this. But this is just to illustrate the syntax for how you do that. And then you can take it a step further, and you don't have to. You're not just limited to applying your function on a single column in your data set, but you can apply your function to the entire data frame. So in this example, you were just applying to a single column. By removing the column part, you can apply a function to multiple columns in your data set. So here, I'm passing the x in the anonymous function is a reference to the data frame. And so to get a specific column within the data frame, I reference it just as I would any other data frame with the period accessor. So x.year.max minus x.year.min is just giving me the range. And it's giving me the range for each shape. So let me go ahead and run that on that line.
Would it matter if you didn't put a space and dash? Looks like it's
It wouldn't matter, but this is, like, you could do this. It would give you the same result. But this is just better Python style to put spaces.
I just get confused sometimes. It means that spaces sometimes you don't. Different.
I would say, pretty much I'm not a super specific about the Python styling, but there's a Python style guide that you can refer to if you ever have a question about these kinds of things. But for operations like addition and subtraction, you generally want to put a space in between. If you're calling a method or attribute, obviously you need to have the continuity there. But these are two different values that you're subtracting one from another, and how to separate them out. So you can say, hey, this is not, there's a one variable, these are two variables that you're doing something, interacting with. Yeah. Yeah.
Can you explain what the syntax for that? Do you always have to use lambda and then your input variable, or is there you should use any?
So let's try a different. Let's try just like func.
It's not.
Invalid syntax. This is just the standard. Unless before saying anything else, let's try something else. Instead of x, let's do let's just say df for data frame. Let's change this to data frame. So the x part is customizable. You can call it whatever you want to. All the examples that I've seen use x just as a convention. Lambda is specific to like the Python syntax, and that's the Python name for an anonymous function. Yeah. If you have questions about anonymous functions, if you don't have a programming background, happy to talk about that more offline. But it's a common programming concept.
It's year is a column, right? It's data frame.
Yes. Yes. Year is a column that we created.
So you said the difference between the first one was you're applying it to.
So here, this x is only a reference to the year column. Here, the x is a reference to the entire data frame. All rows in the data frame. So another way to think about split, apply, combine that some people find helpful is a for loop. It's one line of code that's writing essentially, conceptually at least, a for loop. So you could conceive of writing a for loop and saying, okay, go through this data frame section by section, and for each section, subset a small portion of the data frame, just representing that section, apply a function to it, and then append it to a new data structure, and then go through and do that over and over again. This is just vector. It's just in one line of code doing what it would take multiple lines of code to
So you're doing that for the second one, the whole data frame, but when you're just moving parts, like so you have to specify the column up front, the one up top, and now you put it in the function. Okay.
Yeah. So another way of saying what you just said is just to say that these two statements are equivalent. Now, why would you use one over the other? I typically use this because the functions that I find myself using are more complex and they require more than one column. But that being said, if it doesn't require more than one column, this might be more straightforward because you're specifying right up front, hey, I'm only using this column in this apply function.
What if this is just a syntax question? So you happen to have a column called year because it doesn't have any spaces in it. You can just say dot year.
Mm-hmm.
So, but what if you had like fiscal year, fiscal space year?
Sure.
You have to do the brackets. You have to say data frame dot data frame brackets.
I think it's just this. That's a good question. Let's try it out. Yes. There you go. So if you have a column name that has space in it, and you can't use the period accessor, you can just specify it just as before, but without the period. So it's sort of the same way of accessing the columns, just in general. No, did you have a question? Oh, okay. Oh, good. Great. Okay. So this is the last thing I'll say about this. You can define your own functions outside of the split, apply, combine routine, and this is something that I found to be useful. A couple of reasons why you might want to do this. The function is really complex, and you want to call it multiple times, not just only in this one instance. Another reason might be you want to build an error handling, and it just gets all jumbled together when you specify it within the apply parentheses. So I do use this a lot personally. So here I'm going to define a function. For those of you who don't know or don't have the base Python background, the def indicates you're defining a function. Python is sensitive to white spaces, try, and except. This is just a very basic error handling. So if this works, if it returns a value, then return this value. If this throws an error, then return an empty string. This is, if you didn't put this in there and you just tried to say return your max, and maybe some of yours didn't have a max, which doesn't make sense in this example, but sometimes errors would happen, you wouldn't get any of the results. It would just throw a big error. So this is going to be beneficial for that. And you can see it returns the same result in this trivial example, but this is the syntax for defining a function and then calling that function as a part of your split apply combine routine. And you see I'm calling the function here, get your max. So this line 188 is there's a lot happening, and this is one line of code. You're calling a custom function, you're splitting data, you're applying the custom function to however many variables in your data you want, and you're combining them back together. All of those things are happening in one line of code. So I actually think that's pretty nice. Yeah, Noah.
So, you can't use the custom function for where the lambda is. You have to call an anonymous function of that input.
So the custom function is different than the anonymous function. The anonymous function is a reference to what you're grouping, and the custom function is a reference to what you've defined, what you want it to do with the grouping. So the anonymous function is just saying is there for referring back to the data frame that you're splitting and applying on. So it's sort of two different purposes to it. Yeah. Okay. All right. Well, we are right up on the hour, so I'm just going to close out. I won't go through the merging data section. You can do that on your own time. Writing data is very simple. It's just a toCSV method. I included a section for some other useful features that I use sometimes. How to map one variable to another variable. How to stack and unstack data, which is essentially a pivot table-esque operation that you can do on your data. How to randomly sample data sets, how to adjust specific values within your data, and so forth. But I'm not going to go over that because I want to give enough time for the exercise. But I did want to give some analysis that says some pretty interesting things about alien behavior and how alien behavior is curiously human. So here's the first graph that I'll show you. And let me see here. If I can get this to work, that is. UFO group by. Well, I will come back to that one. Man, it's weird. I'm not sure what's going on. Apologies for that. I'll fix that and come back to that one. Yeah, I didn't really transform anything though. Index out of bounds. Group by. Okay, well I'll come back to that one.
maybe I'll just come back to this whole section if I'm getting problems here. So here's a graph that I thought was interesting. It shows the time of day, so alien sightings plotted over the time of day, and the number of UFO sightings. Because based on common sense, one would not necessarily expect alien behavior to follow human behavior, because a 7-hour week and a 24-hour day don't make sense outside of the Earth. It only makes sense on the Earth. But here you do see sort of an interesting trend, and the trend being that you tend to see more UFO sightings during the night, and also you can't see it here, 4 and 5, which are Fridays and Saturday nights. So it appears that UFOs tend to follow the behavior, college frat kind of behavior. So this may be what is that supposed to mean? It may be speculative for me to say this, but I'm just going to throw it out there, and I'm going to say, I think aliens do enjoy keggers. So that's what I think we can infer from this data. The second thing that I'll show you is that this is actually, oh man, what is going on here with my plotting? Oh, that's. Let's try this. Okay, here we go.
It clears everything.
Okay. There must have been some setting that I messed up there. Let me actually do... So here's a plot that shows UFO sightings in the month of July for the past 4 years. And the noticeable feature here is the spike in activity on the 4th of July. So if any of you guys have seen the movie Independence Day, I hate that movie. I think it's a complete slander on aliens. Aliens genuinely love America, and they come here every year for the hot dogs, the fireworks, and to have a good time. If they were bent on destruction, the White House is still standing, so I don't think they're bent on destruction. I think they're here for a good time, for the fireworks and for the hot dogs.
All aliens are American.
Yes, aliens are patriotic. They love America. They are not bent on world destruction and domination, as Independence Day would lead you to believe. And let's see if this last one. No, it still doesn't work. I'll come back to that one. But, okay. So that being said, a little bit of fun there. What I want you to do now is we're going to do some human learning on data, which is basically just a way of saying we're going to explore the data and try to find some patterns in a new data set that many of you haven't seen yet. And we're going to basically just give you guys the opportunity to do this on your own. But we gave you some guidance in this exercise in the comment section. And so if you open up the O3 IRIS pre-work, you'll see instructions on loading the IRIS data set and importing the packages that you'll need, and then comments that guide you through a journey of exploring this data, learning the features of the data, learning the patterns in the data, and trying to use what you learn about the data to actually make predictions based on the data that you see. And so this will sort of be our pivot into just purely exploratory data analysis into the exciting world of machine learning. So we're just going to take some time, think about this, go through these exercises, and we'll do this until our lunch break.
Feel free to work in groups too. Don't feel like this has to be individual.
A bunch of friends.
All right.
Got
Got it? Great. Artwork, folks, we are back. We are going to get started again. So, raise your hand if you were able to complete the exercise. The exercise, okay? Raise your hand if you're able to complete 75% of the exercise. So all of part 1 and half of part 2. No? Okay. Good, good. So what I want to start off with the class today with is just going through the first part of the exercise and making sure that everybody is all on the same page and making sure that we all understand what's going on in the first half of the exercise. And then I'm going to set you loose once again to tackle the second part of the exercise, and we will go from there. So I have a solutions file which I will be giving you after class. I'll put this on GitHub, and I'm just going to walk through step by step each of these mini exercises. Okay, so we are loading in the data, and this is something I'll mention. I got some questions about this. This data is contained in the sklearn package, and it's something called a data bunch. So if you type in type iris, you get data sets bunch. And so this just means this is a bundle of a lot of different information about a data set. It's just the way that it's stored. And the way you access the information about the data set is through these attributes, the periods and the different attributes that were listed out in the beginning of the script. So let's talk through really quickly, what do these attributes represent? So this first, just typing in iris.data. If I were to ask Noah, what does this represent?
It's an array of lists.
Okay, so it's an array of lists. What does it represent conceptually? Not technically in terms of Python, but what is it? What is it actually describing?
Oh, like so next things are. So I think those are the 4 different measurements of the iris column.
Okay, yeah, exactly. So exactly, there are 4 different. It's structured in a format that you have 4 different columns and lots of different rows. How many rows are there? Let's find out by calling the shape attribute. You can see there's 150 observations or rows in the data set, and there are 4 columns in the data set. Okay? So what is this? Iris dot feature names. Joe, what is a feature name in this case?
It's a list that each one might have a bunch of 4
Exactly. It's a list, and each element in the list corresponds to a column in the data. And here, it's called something interesting. It's called a feature name. A feature name. So if you're not familiar with the terminology, the machine learning lingo, machine learning terminology, features are references to columns in your data, but not just any columns in your data. Usually they're references to what would be called explanatory variables or input variables. And so when you think of a feature, when you describe a feature, we'll talk more about this in the machine learning introduction, typically you're talking about some kind of collection of metrics that's going to describe something that we're interested in learning about. So that brings us to iris.target. As you can see here, iris.target is an array of 0s, 1s, and 2s. What do you think that iris.target represents in this data set? What's that?
The number code that relates to the species of iris, I guess.
Yeah. Yep, exactly. So 0, 1, and 2 correspond to 3 different species of irises. And it's called a target, which is, again, another common way in machine learning lingo that a computer scientist would refer to what you're trying to predict
what you're trying to explain, what you're really trying to understand. So in this case, if you are doing machine learning, and we'll talk about this more later today, you might be interested in saying, what are the properties that identify, that uniquely identify and indicate different species of iris? So we've got 3 different species here, 0, 1, and 2. We don't know what that 0, 1, and 2, we don't know what that represents. And we want to know what are the properties of these 3 different kinds of iris species. Okay?
Have like a reference about like the lineage of those terms that you just talked about.
Yes. Yes, we do. And so now we'll be going over that in momentarily. Like the nomenclature, features, and targets. Yes. So, but I'll just draw it on the board for reference for right now, so that. So we're starting to sort of make some sense of the structure of our data, and I'm just going to draw out what the data looks like. So we've got a target, which is, in this case, it's in a separate array. But for the sake of illustration, I'm just going to put it in a separate column. So we're going to put it in a column momentarily. And this is 0s, 1s, and 2s. And then we've got sepal length, sepal width, petal length, and petal width. Actually, I'll call this. I'll put this. Call this the species. And in this data set, these are my observations. These are my features. And this is my target. Okay? So again, the four columns of data that we have in iris.data, those are the features, the 4 features of our data set. And each row is an observation, a single record of a single flower, in this case. And then each flower has a target, a species that's associated with. A 1, a 0, a 1, or a 2. Okay? So now, with that being said, what do you think target names represents? Yes, exactly. And so instead of 0, 1, and 2 here, we could put in Setosa, versicolor, and virginica. These are the same things. They correspond to 0, 1, and 2. The reason they were stored this way, presumably, is because text takes up less information than numerical values. So, what is this data structure that we see? I think, Noah, you said it was an array of lists. What is this? What is this data structure? Well, if you type iris.data, you'll see exactly what kind of data structure it is. And it is actually a NumPy array. NumPy stands for numerical Python. And I mentioned earlier, and I'll say it again, that Pandas is built on top of NumPy. So what is the difference between a Pandas data frame and a NumPy array? No. Nothing? Anyone else? Numbers versus other kinds of data? Okay. So
they're not mutually exclusive. After all, Pandas data frames are built on top of NumPy arrays, but NumPy arrays only have one type of data in them. So they're all going to be strings, they're all going to be integers, they're all going to be floats. Okay? So you can have different columns with different data elements, and Pandas data frames can. You know, you can have time in one column, and you can have string in another column, and you can have integer in another column. And there are no labels on a NumPy array. It's just the data in tabular, structured matrix format. Okay? If you would like to, and like I mentioned, all Pandas data frames are built on top of NumPy arrays. So for any Pandas data frame, you can access the underlying NumPy array. We'll do that in a moment, so I'll show you how to do that. But the benefit of using a NumPy array is that they're lighter weight. There's less information, so you can process information very quickly. It's only one type of data, so that adds to processing speed. The downside of using just a pure NumPy array is that you might not have as much of a sense for what the data is actually representing because you don't have the row labels, the indexes, the column labels, and you also can't have different kinds of data in the same NumPy array. Okay? If you would like to learn more about NumPy, we're going to do a little bit of NumPy arrays. If you'd like to learn more about NumPy arrays, someone, and this might have been you, Sinan, it might have been someone else, put together a very helpful primer on how to work with NumPy arrays. And that's on the GitHub account right now. Sinan, was that you that put it together, or?
It was me and Kevin.
It was you and Kevin? Okay. Very, very useful. I really appreciate that. So here we got the data. So now we're going to do something that I saw a lot of people sort of struggle with this aspect of it because we never explicitly went over it in class. So the first request was read the data into a data frame. So how would you have done this if I didn't actually tell you exactly how to do this? Here's how I would have done it if I was given a task in Python that I didn't know how to do it. I would type in something like how to convert NumPy array to Pandas data frame, something like that, into Google. And I see a link to Stack Overflow. Let me try to pull that link up. Wait, can you see that okay? Right. Is that okay? So here's an example where there's a question, and then the first thing I always do when I go to Stack Overflow is I go to the answer section, and I see is there an answer that's been given the blessing of the green check mark. And if there has, I'm like, okay, I'm going to listen to it. I'm going to pay attention to this. If there hasn't, I just skip it. That's just a personal thing that I use. So I don't even really care about the structure of the NumPy array, but there's a question and an answer here. And I don't know exactly what's going on. I don't even really read the question because I know what the question is, and the question seems to be the same thing that I have. So I just scroll down here and I say, okay, it says, I don't know what this is, reshape. I'm not sure what that is. Let's just skip that for right now. Here's the part that I'm looking for. It's a pandas method, which makes sense because the data frame is a pandas idea. And here's pd.dataframe. So pd, again, this is like the common convention for pandas is you use the alias pd. It's like, okay, this is on the right track. pd.dataframe. Okay, so this converting to data frame is as simple as just typing in data frame. And it's capital D and capital F. And it's a function. And the argument to the function is data. And that's all I would check for the first time I would try it. I wouldn't even worry about what this rest of this says. I would just say, let me just try taking my data and just throwing it in here and seeing what happens. And if it doesn't work, I can go back to this, maybe go for more details, go to a different answer. But when you're learning Python, Stack Overflow is your best friend. So here, I'm going to just do what I said a moment ago, and I'm going to take out this columns argument. I'll come back to that in a moment. And let's see what this gives me. Okay, so it didn't give me an error, so that's good. What does this give me? Oh, that's exactly what I was looking for. I converted my data into a data frame. But wait a second. I got these column labels 0, 1, 2, and 3, and that's not very informative. Do we have feature names? Yes, we do have feature names. We do have column labels. Is there a way to incorporate that information into the data frame? So one thing I might do is look online for the 2 data frame documentation. Another thing I might do is just type in help and then pd.dataframe and look here in the documentation for the parameters that it takes. Pandas, as you can see, Pandas, there is a lot of documentation here. so maybe that wouldn't be the most helpful way in this particular case. Regardless of how you find out how to read that in, one way of doing it is just specifying columns equals and then the column names. And as long as your array has the same column order as the list you pass to it, and remember again, this iris.featurenames is just a list, it will match up. It will match the first element in the list with the first column in your NumPy array. Okay? Any questions about any of that? No, that's a lot of information.
This will match the first column.
So, good question. So here I've got my data set, and there's 4 columns, right? And here I've got my feature names, and there's 4 elements in the list. So when I pass this, it maps the first element in the list to the first column, the second element in the list to the second column, and so on. So the order stays matched up. It doesn't like sort it around.
Yeah, that's a lot more elegant because I can type out each one individually. Like rename this, equal this, rename this.
Yeah, that's another way you could do it. That's another way you could do it. You could type in, use the rename method for the data frame. But this is nice because you just do it all in one line code as opposed to 2. So the next task was, so any other questions on that? Okay. So the next task,
How did you know, though, from that previous stack piece that you could do that function inside there?
I didn't know that from the stack piece.
I'm just saying,
So
like,
this piece right here?
the whole part within the parentheses, because before the other one was a dictionary, right?
Hmm?
How did you know that you could use pd.dataframe out?
Yeah, that's a good question.
Dictionary column?
So the very general answer is that I don't, but I'm going to try it and see what happens. A more specific answer would be, the data frame is a very common data structure. NumPy arrays are very common data structures. Lists and dictionaries are also very, very common data structures. So it makes sense that if you have a very common data structure, you would want to be able to go back and forth, and this function would support that. Another answer would be you could actually go to the website and look at the documentation for the function and read the specifics of it. There's lots of different ways to go at it.
I guess when I do it, I get stuck. I try to just recreate exactly what they did in Stack Overflow.
Mhm.
Just input my functions or features instead.
Yeah. I mean, that's another way to do it. But that's not the most efficient way. And I mean, maybe the first time I looked at this, maybe I would have done something much less efficient, and then over time, as you learn more and more, you learn about more elegant, more efficient ways to do things. So if there's something on here that looks like I have no idea how I would have ever thought of that. Like, that's okay. Use this as a learning opportunity to learn the specific example and approach your work with a mindset that how can I make what I'm currently doing more efficient, more elegant, and write less code to do the same thing. Yeah?
I want to dig into that statement you just said. I would never have thought of that. So I've been teaching math for a long time, so I get this a lot. Like, you're teaching calculus, and you do this cool, you do a proof, or you teach this cool little trait in calculus, and someone says, but like, I would never have thought to do that. It's not fair. I'm like, well, listen, if you had thought to do this, you would be Isaac Newton. So it's fine that you couldn't think to do this because no one else did for hundreds of years beforehand. The whole idea is, yes, there are going to be some things that don't seem intuitive right away. It's like, oh, that makes, I never would have thought of that. That's the point of school. It's because sometimes there are people who've been doing this for a very long time, and we figured it out the hard way so that you don't have to. We're just going to tell you what took us 20 hours of headbanging and Stack Overflow to figure out. This is the trick you have to do. So never be afraid of, oh, I never would have thought to do that. Now you do. Now you will.
Mm-hmm. Yeah.
Especially, math is,
I never
I never would have thought to do it in Google.
Yeah.
But can you just read that across like the whole function now? Like
Yes.
that equals.
So I'm creating a data frame, and I'm creating a data frame on this right-hand side, and then I'm setting it equal. I'm assigning it to this df variable with the equals operator, and rather left to right, I'm doing something with the Pandas functionality. I'm accessing the Pandas functionality. I'm calling a method called dataFrame, which creates a data frame, and the arguments to that data frame are the data that I want to convert into the data frame format. That's the first argument. That's the main argument. And so if I were, let me come back to that. So the main argument is just the data that I want to convert into a data frame format. And then I want to also tell my data frame, what are you going to call columns? What are columns? What are the column names? What are the feature names? So I'm going to say columns equals iris.feature names. And this could be a dictionary. I think this could be a dictionary too. It doesn't have to be a list. But I'm just saying, I want to take this data, I want to turn it into a data frame, and I want to give it these column names. That's all it's saying.
You could have stopped right after the data and just put in parentheses.
Mm-hmm.
Could you also do rows then, like columns and all that, and then kind of comma rows equals and then another?
Oh, that's a good question. I'm not sure. Yes, you can. Yes, you can. It wouldn't be rows. It would be index.
Wait, is that line pull under the prime?
No, it doesn't. It does not.
Well, we can append the features. We can append features to that as another column, right?
Yes, which we will in a moment. Yep. So if you look in the documentation, it'll tell you how to add an index. So a row label is just usually referred to as an index. I mean, technically a column is an index as well, but to add rows, to say, I want my index to be, instead of 0 to 150, 150 to 0, or whatever it is you want to make it. A's and B's alternating by 1, whatever it is you want to make it. You can do that within this line of code. Yeah. Okay. Cool. Moving onward. Now we're going to clean up the column names. And I love this line of code. I actually didn't write it. I think Sinan wrote this, so great job, Sinan. It's using a base Python concept known as list comprehension. And what list comprehension is taking a for loop, and sometimes an if statement as well, but taking a for loop, so something that's iterating over a list of something, and consolidating that for loop, which is usually a couple lines of code, into one line of code that returns something in a list format. Okay? So what we're going to do in this list comprehension is take the feature names, which are sort of ugly in the way that they're defined, there's spaces, there's extraneous information in it, and we're going to strip out some of that extraneous information, and then we're going to put it back into a list. So the input is a list, the output is a list, the internal mechanics of what's happening in the list comprehension is just a for loop. And so it reads as follows. Using the for here, which indicates that you're having a loop. So for name in iris.features. What does that do? Iris.features is a list. Feature names is a list. Just the 4 string elements in the list. And then it's creating an iterator object called name. And what this will represent will vary based on what iteration of the loop you're in. So the first iteration of the loop, it will be sepal length. The second iteration will be sepal width, pedal length, and pedal width, etc. And it's going to go through, and this name is a reference that we've used over in the structure, the body of the list comprehension, which would be like underneath the for loop part if this was a for loop. And what we're going to do is we're going to take the name, which is a string, and we're going to take everything, the entire text of the string, up to the fifth element from the end. So let me just show what that is. So iris.featuresNames.0, that's one element. So let's just call that name right now, just for this example. So name everything up to the fifth element of the list. Interesting. And the reason you can use this functionality is because you see this, the first element, second, third, fourth, fifth. And it's the same, it's consistent for all of them. So even if you have to look for the specific text itself, you just look at the relative position. And so this name, that up to the negative fifth, will just return what you want. That's the first breakthrough, okay? The second breakthrough is using the replace method, which is just a method you can use on any string in Python to look for this blank space and replace it with an underscore. So let's do that on this example. And you see how that works there. It looks for the blank space and then it replaces it with an underscore. You can also just put them together. There's lots of different ways of doing this, but that's one option. So it uses very... the first time I saw list comprehension, it was confusing to me. And it took me some examples to get used to it. So if this looks foreign to you, if this looks cryptic to you, I encourage you to take some time this week and do a list comprehension on your own, just to make sure you're really comfortable with it. Because we're going to be using list comprehensions a lot in this course, and you'll see them in a lot of code. It's a very common programming construct, and it's a very popular programming construct in Python, but it is a little bit cryptic the first time you see it. Yes?
So the name part starts from the end of the string, and the replace part starts from the beginning, correct?
The name parts, so the colon indicates starting from the beginning up until the negative fifth element. So the fifth element from the end. Replace, it actually looks for every instance. There's like find every instance of this string and replace it with this string. So the order doesn't really matter. Yeah.
And that was comprehension. So that was in response to someone in the previous class asked, well, this is great, we want 4. I can easily manually change them. What if I'm measuring 1,000 things in centimeters? And my response was, well, list comprehension. So the whole point of that list comprehension is that in one line of code, you are replacing every single column space with underscores. In any column name, if there was a centimeters, it's gone. Like it was for every single column. How many there are.
A little challenge exercise. If you guys are like, yeah, I got this list comprehension stuff, just move on, please. If you haven't tried it yet, try putting an if statement in here. And if you've done an if statement, try doing an if-else statement in addition to this. So like some column names have centimeters, some don't. What do you do then? Can I still use list comprehension? Yes. Yes, you can. It just needs a longer statement. But
If you had a mix already with the underscore, like sepal underscore length, but then you also had a sepal space width. If you run that, it just skips over.
yeah, it would just skip over because there's no space to find.
There's no space now.
Yeah. Okay, any questions about list comprehension? Okay. So now let's do what we did before, but now we have these better column names. And so now let's take a look at what our data frame looks like. Much better, much more tidy, much more easy to work with. So now what we're going to do is create a list of species. Okay? Right now what we have is this iris.target, which is 0s, 1s, and 2s. Let's change 0s, 1s, and 2s to the actual species names. Okay? This isn't a huge data set. It's only 150. We're not going to waste any memory, 150 observations. Let's change it to the names so we can actually have some of that interpretability. How are we going to do this? We're going to do it with another list comprehension. So, if you're tracking with me so far, I'm going to tell you one thing about this, then I'm going to ask for somebody to explain what's going on here. So first of all, you've got iris.target names, which is just a list of 3 elements. It's an array of 3 elements. Second of all, you've got these brackets, and what these brackets do is access elements within this list. So this is the 0th element, the 1st element, the 2nd element, and there is no 3rd element. Okay, there's no 3rd element. Okay, just like a list in base Python. This is a maybe it's not exactly a list, but for all intents and purposes, it behaves as a list. So, with that being said, with what I just told you, that you've got a list here, and you're accessing different elements within the list, somebody explain to me how this list comprehension is working, how you understand and conceptualize what this list comprehension is doing. Anyone wants to give a stab at it?
So
Yes.
So it's going to start pulling elements from iris.target and then putting those into the call for iris.target underscore names. And it's going to do that for all of iris.target and spit out a list of those elements.
Okay. So that's a good explanation. Very good. So iris.target again is this list of 150 0s, 1s, and 2s. Okay. So you're going to iterate through 150 iterations. This comprehension is going up 150 times. So num is going to start at 0, 1, 2, 3, 4. Actually, sorry. Num is going to go 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2. Okay? And for each num, a 0, 1, or 2, whatever it is, it's going to take the 0th, the 1st, or the 2nd element from this list. Okay? And it's going to return a list. So let's just run this line of code. And you can see that it returns a list just like we expect. A bunch of Setosas, then versicolors, and Virginicas. Because that's the way the data was ordered. 0s, 1s, and 2s. Does that make logical sense? Yeah? Yes?
So the order of the target names matter. But if you can't have a 0 be put to another name than it should be. You know what I'm saying?
So here's what matters in the order, and here's what doesn't matter.
Okay.
The 0, 1, and 2 corresponding to Setosa, versicolor, and Virginica, that matters. Because you're always calling a 0, 1, or 2 to that list of target names. So that matters. You've got to understand that mapping. You know, that mapping is just built in here. That's the way they set it up. But the order of the observations in your data frame does not matter. It could be like 1, 0, 1, 2, 0, 1, 2, 0, 1, 2, 2s and 1s and 0s. That doesn't matter. Because the target name that's being assigned is being assigned according to the target value. So as long as this target value, target name relationship is understood, then this will work regardless of the sort order of your observations. Does that make sense?
Yeah.
Okay. All right. So we're going to create a list, and we're just going to turn this list into another column in our data frame. This is something I actually did not know, but it makes sense. You've got a list, and it's just a one-dimensional list, and you just assign it to another column, that you've never done before, and you can create a new column in your data set like that. So now, when we see df head, now you see the new column there, the species column. Okay? Now what we're going to do is we're going to get into describing the data. So exploring the data. So this is something that you'll do on your own project. This is the kind of process you're going to do on your own project. Describing the data, exploring the data. And so this is using the stuff that we just learned about in the pandas. Okay? So first of all, I'll call the df.describe method. And this isn't super helpful. I mean, it gives you, some summary statistic about each column. But what we're trying to get at is differences between different species. So that's not super helpful in and of itself. So what I'm going to do is call the group by method. I'm going to group by the species column. And I'm going to take the average of the sepal length column. Okay? So this gives me, Setosa has an average of 5, Versicolor is 5.9, Virginica is 6.5. Oh, that's interesting. Maybe there's some differences there. Not totally clear just from looking at that data point. But that gives me an idea. Why don't we look at all of the columns and averages for all of the columns by species? So what I'm going to do is type out, so this is the same thing as before, except for instead of just the sepal length, I'm going to give it all of the columns that I want to, and then call the same function afterwards. And by the way, I'll put this file on GitHub, so you guys don't need to scramble frantically to write all this down. You're more than welcome to if you'd like to, but I'll put this on GitHub by the end of class. Species is the one column, yes. So this is how our data is structured here. You see it right here. Sepal length, sepal width, petal width, species.
We're just looking at that right column.
We're grouping by this column. There's 3 different values in this column: Setosa, Virginica, and Versicolor.
About that one by one.
It's a one-dimensional in the sense that it's just a single column, but there's 3 different values or 3 different levels of data, different species.
You bring out the whole thing.
Yes. Mm-hmm. Yep. You can.
I thought when you said a one dimension, I thought you meant that the whole column was like every entry. You're saying
There you go. 50 Setosas, 50 Versicolors, and 50 Virginicas. Make sense? Sorry for not explaining that clearly. Okay, I'm going to skip over. Actually, no, I'm not going to skip over this. So you see, okay, is there differences? Maybe there is, maybe there's not. Mean might be a good way to go. First off, you've got, the sepal lengths, 5, 5.9, 6.5, sepal widths, 3.4, 2.7, 2.9, petal length, 1.46, 4.2. Okay, there's a difference. Petal length, Setosa petal length seems to be a lot shorter than the other 2. Those are the kinds of clues you're looking for. Oh, that's a difference. 1 to 4, and 5. Huh, okay. There's nothing else. Petal width, 0.2, 1.32. Okay, so Setosa is a lot smaller than the other ones, it seems to be. And Versicolor seems to be, a lot smaller than Virginica. Okay. So this is the kind of summary statistics that you're trying to look for if you were exploring your data and trying to understand the properties of the data in your data set. So, now the question becomes, and we'll plot this. Let's continue to look at this, because I would say this is a quick clue. This doesn't tell you anything conclusive. Depending on how dispersed your data is, this might actually not be as significant as it looks. So let's look at some plots. Actually, before we look at some plots, let's take the data down a level of granularity and look at the raw data itself. But let's sort it so that we can see some of these patterns that we are suspicious of that we think might exist. So I'm going to skip over sepal length, sepal width, because I don't think they're super interesting based on this. But let's look at petal length. Remember, our hypothesis is that setosa seems to be shorter than versicolor and virginica. So what I'm doing here is I'm doing the sort index, and I'm specifying the column I want to sort on, and then I'm calling this values attribute. What is this? This is the underlying NumPy array. Why am I calling it? It's really just out of convenience. I want to print the entire data set. I don't want it to truncate the observations. I just want to see the entire data set, okay? This is the underlying NumPy array, and you can see that I'm sorting by petal length, which if you remember from up here, petal length was the third column in. So we're looking at the third column in. This is what I'm sorting by. This one right here. And tell me if you see any patterns here on the kinds of species here. Catch anything? Let me scroll through it again. Let me go to the top. I'll scroll down again. Scrolling down, scrolling down, scrolling down. Okay. Any interesting patterns jump out? Nope.
Yes.
Yep. What?
So it's sorted by species. So Setosa is always at the top. So yeah, and the Virginica is at the bottom.
Yeah. That's an interesting pattern. It's not just the median value. If you actually sort it, it really seems like all the Setosa the Setosa species consistently have like a shorter petal length than other species of flowers. So if you're trying to understand the properties of these flowers, that's a clue that you can look at. Let's look at another one. Let's look at petal width. You see a very similar pattern: Setosa, versicolor, and virginica. The difference, they're actually pretty similar, I would say, in terms of what you're looking at. You've got sort of one species, then another species. So let's just look at this visually, which is easier to look at. Let's look at the petal width histogram, and let's split it up by the different species. So here we see that as we sort of expected, the Setosa is less than 0.5. This is between 1 and 1.8. This is between 1.5 and 2.5. So there does seem to be this delineation here between the different species just on this one variable alone. Let's look at same kind of thing, but with a box plot. And you see a very similar kind of story. The petal width seems to differentiate to an extent between these different species. Let's look at the same thing, but on a scatter plot. Show you this. So petal width versus petal length. These are the ones we identified as being the two sort of more interesting variables. And you can see the species that are in the color, and there does appear to be differences between these species. And then one last way that we can look at this would be on the scatter matrix, which is just all the pairwise combinations of the variables in our data set. And here's the one we were looking at earlier: petal length and petal width. So that being said, we're at 2:50, and I told Sanat I would be done by 3 o'clock, so I'm going to stick to that. And I'm just going to keep marching through the second part of the exercise. I'll go through that really quickly, but I want to stop and ask the question. And this is sort of leaning into, we're making a transition from the world of data exploration, merely like exploratory data analysis, into machine learning and predictive analytics. So in this case, if I was to give you the task of predicting the species of observation based on the attributes in the data set, how would you think to do that on a conceptual level? Not on the code, but just conceptual.
Use the values as inputs for the different lengths and widths and kind of see where they best fall, which species they best fall into.
Okay. So what do you mean by the different values?
Better length.
What's that?
Better length. Better width.
Petal width. Okay.
Those are the most differentiated.
So right now, if you've been following along with this, you would have the ability to write your own predictive algorithm, machine learning algorithm, without using any additional tools. Everything is something you know. You could write it from scratch, just based on this exploratory data analysis. How would you do it? Well, basically what you said is you take the features that are the most informative features in your data set, and you use those features to predict whether or not future other features, other examples, will be in one bucket or another bucket. Okay. Do you guys want to see the code real quick? Okay. Let's fly through this. First of all, I am going to create a dictionary called IX. This is just a dictionary that maps the name of the column to a number. This might not be obvious why you would want to do this now, so I won't linger on this. This might be one of those things that after trying it initially, this would make more sense and you would come back to it later. Then the function to classify the iris into one species or another, or predict which species it's going to be, is going to be as simple as an if statement. An if statement based on the features, the informative features that we've already decided. So without going into all of the syntax here, the logic is as follows. If this is something that would go through row by row for each observation. It takes in one observation and it makes a prediction. Or it takes in 5 observations and it makes 5 predictions. So for each row, if the petal length in the row is less than 3, then return setosa. Else if the petal width is less than 1.8, return versicolor. Now if you're following with me, you'll notice that the petal width less than 1.8 doesn't necessarily differentiate a versicolor from the other 2 species. But it does differentiate a versicolor from a virginica. And we've already identified the setosas. So let me say that one more time. So the first thing we're going to look for is the petal length less than 3, which in every case we saw in our data set was always a setosa. So we're going to call that setosa. Then, once we have all of the things we think are setosas out of the way, the next check we're going to make is whether the petal width was less than 1.8. Now, the setosas were also less than 1.8, but we're banking on the fact the patterns we see in the data are also true for future observations, and that if it was setosa, it would have been registered by passing this initial test. So it checks for setosa first, because that's easier to identify, easier to isolate by itself. And then it goes to versicolor, which is slightly harder, and it says that if petal width is less than 1.8, then versicolor. And if none of those are true, then just call it virginica. Okay? Because of the time, I'm not going to explain all of this logic, but we can talk about it in the break, or you can talk about it after class. But for the time being, I'm just going to go ahead and define this function, which again, as I said, operates on a row-by-row basis. And I'm going to make some predictions. So here, I'm going to call the classify iris function that I've just defined on every row in my data frame. So for each row in my data frame, I'm going to call this function. I'm going to convert it into a NumPy array. And I'm going to call it preds. And so you can see these preds are in the same kind of format as they're just these three separate values. And then I'm going to calculate the average of the accuracy. So preds equals df species.values. What does that mean? So df species.values is just true observations. That's the truth. Preds are what we predicted the truth would be. Looks very similar. And equals is just going through. This is a vectorized computation. And it's going through and it's labeling true for all these or false. And I mean, it looks like you did a pretty good job. So good job on that, guys. And so we're just going to take the average of that, and it treats the trues as ones and the falses as zeros, as you would expect. And 96%. Actually wasn't that difficult. No special, no like crazy, packages to do machine learning. This is purely coding by hand with a little help from Pandas. But yeah. So that's that. So in the remaining couple minutes, any questions about this? I know I didn't take the time to explain this syntax, but I'll let you, and this syntax as well, I'll let you think about this on your own, maybe Google it, talk to me in office hours, talk to us during the breaks, talk to us after class. But aside from some of the particularities of the syntax here, which might not be totally clear, any questions about that whole process? Yeah, John.
When you're doing your check there, can you define a certain width of error? So say you want to be, I guess with true false is the mark, but say you have gave yourself a 5% margin of error. Could you put that into that loop?
So you can see, so with the case, in this particular case, you could tell your error rate. So this would just be, maybe one minus this would be like your average 0.04% of the time you get it wrong. In terms of like a tolerance or a range of errors, that might make sense if you're looking at percentage accuracy. There's another class of prediction algorithms that we will cover in a future class. And there are different ways of measuring different kinds of prediction problems. Essentially, the two kinds of prediction problems are you're predicting a bucket, a category, true, false, Setosa versus the color Virginica. Those are called classification problems. And then you've got problems where you have a continuous variable you're trying to predict. How much is the stock market going to increase? How many times will this post be retweeted? What is my salary going to be in 5 years from now? And continuous variables can take any range of values. And Sanaz's going to go in much greater depth into that in just a moment, talking about the different kinds of machine learning problems. But and then we're going to also be going into greater depth in terms of how you evaluate accuracy. So this is just scratching the very surface of how you do that. Good question. Yeah.
So will the evaluation get into statistical significance?
Yes, it will. Yes. Any other questions? All right. Well, with that, I'm going to go ahead and turn it off to you. You were on.
Pass.
It's nice you can say that.